The central contention of evolution of consciousness theory is that humanity today marks an inflection point in time. Through the human experience, the universe crosses the threshold to meaning and sets forth into its final evolutionary period, the age of fulfillment. As we cross the threshold to meaning, we move beyond socialism, capitalism, and scarcity-based economics. Humankind embraces the free and creative form of economics we call economics of fulfillment. Economic transformation, in turn, will open the way for an outpouring of creative activity such that humankind has never before experienced. In this, our third course that introduces the evolution of consciousness paradigm, we explore this outpouring of creative activity, blueprint for Reconstruction. As we have discussed in prior courses, the greater consciousness and autonomy of the individual allows the individual to form stronger social bonds. Greater individuality, greater awareness and substance of character, and not governmental control and top-down authoritarianism, bring forth a less collective, more cooperative society. Greater autonomy brings forth greater unity. Similarly, the greater autonomy and consciousness of the individual allows the individual to align his or her creative efforts with the creative efforts of others to accomplish larger joint ventures. Made possible by economics of fulfillment and by the heightened state of freedom it brings into being, humankind will have the power to engage in ever more grand engineering undertakings. Of these engineering undertakings, humankind's rise from the collective will lock the creative spirit in the most ambitious of all visions, the rebuilding of the Earth's urban and ecological infrastructure. We will strive to mark a fundamental evolution of consciousness leap forward, perfection of life on Earth. As the engineer will tell you, the first step in any building project is to study the site on which the project will be built. In our case, this site is the Earth. Our planet is the third from the Sun and the fifth largest in the solar system. The Earth's orbit is not a true circle. Our planet travels an elliptical orbit with a mean distance to the Sun of 149.5 million kilometers, or 92.9 million miles. The Earth is also not a perfect sphere, but slightly pear-shaped, with a 21-kilometer or 13-mile bulge at the equator, a 10-meter or 33-foot bulge at the North Pole, and a 31-meter or 100-foot depression at the South Pole. Current theory suggests that the Earth formed from a cloud of stellar gas that drew in on itself to create the Sun and planets. Radiometric dating places this event at between 4.6 and 5.0 billion years ago, near the end of what, in evolution of consciousness theory, we call the universe's period of structure. At first, the Earth was a relatively cool and homogeneous mass. Gravitational contraction and the radioactivity of heavier elements, however, caused the Earth to heat and melt. Heavier elements, primarily iron and nickel, sank to the planet's center. Lighter elements, primarily silicates, floated to the surface. By about 4.4 billion years ago, an atmosphere of methane, ammonia, nitrogen, hydrogen, water vapor, and carbon dioxide, with little oxygen, had accumulated. By about 4.1 billion years ago, water vapor in the atmosphere had condensed to form oceans. As a result of the Earth's formative processes, our planet is made up of 5 spherical layers: the atmosphere, the hydrosphere, the lithosphere, the mantle, and the core. At present, the atmosphere is about 1,100 kilometers, or 700 miles, thick, with half of its mass in the lower 5.6 kilometers, or 3.5 miles. It consists of 78% nitrogen, 21% oxygen, 0.9% argon, and 0.03% carbon dioxide, with varying amounts of water vapor and trace amounts of ozone, methane, hydrogen, and carbon monoxide. The hydrosphere is the layer of liquid water that covers most of the Earth's surface. It consists of the seas and oceans, all lakes, rivers, inland seas, and underground waterways. The lithosphere is a layer of hard, cold rock that extends from the Earth's surface to a depth of about 100 kilometers or 60 miles. It consists of the sialic or upper crust, which includes the continents, and the somatic or lower crust, which forms the ocean floors and basins. The mantle extends from the base of the lithosphere to a depth of about 2,900 kilometers, or 1,800 miles. It primarily consists of iron, silicon, and magnesium oxides. The mantle encloses the core, which geologists believe consists primarily of iron. The temperature at the center of the core is hot, estimated to be as high as 6,650 degrees Celsius, or 12,000 degrees Fahrenheit. One of the Earth's most remarkable characteristics is the phenomenon of continental drift. The lithosphere, the Earth's outermost solid layer, is broken into 12 major tectonic plates and is separated from the lower mantle by a zone of partially molten rocks called the asthenosphere. The intense heat in the core, thought to be in part the energy released by the decay of uranium and other radioactive elements, generates convection currents in the lower mantle. These currents apply shear forces to the asthenosphere, which transfers these forces to the tectonic plates. The movement of these plates causes the continents to travel across the Earth's surface and the oceans to open and close. Convection currents also supply a flow of molten rock to the Earth's volcanoes and mid-ocean ridges. In addition to its overall structure, the Earth displays a more subtle design, illustrated by its magnetic field. As anyone who has used a compass knows, however, the poles of the Earth's magnetic field do not coincide with the Earth's geographical poles. At present, the North Magnetic Pole is off the coast of Bathurst Island in the Nunavut region of the Canadian Northwest Territories. The South Magnetic Pole is near the Adelie coast of Antarctica. The position of the Earth's magnetic poles shows daily and annual variations, and a periodic variation every 960 years. On occasion, the Earth's magnetic field also reverses polarity. Studies of residual magnetism in rocks and of magnetic anomalies on the ocean floors show that the polarity of the Earth's magnetic field reverses frequently in geological time, every few 100,000 years, and as many as 170 times in the last 100 million years. By about 4 billion years ago, the first single-celled life forms had emerged. At the time of this development, at the moment the universe crossed what in evolution of consciousness theory we call the threshold of design over structure, the cosmos and all that came before fell into the realm of evolution's trailing arrow. Evolution's leading arrow locked in the design of life. Defined by the evolution of the single-celled organism, the earliest period in the Earth's geological history, the Precambrian, extended from the planet's formation to about 540 million years ago, roughly 88% of geological time. About 3.5 billion years ago, the first cells capable of conducting photosynthesis using a lower, less energetic form of light than ultraviolet had emerged. This allowed cells to create carbohydrates from carbon dioxide and water while giving off oxygen, and led to a gradual buildup of oxygen in the atmosphere and to the formation of an ozone layer. By about 1.4 billion years ago, atmospheric oxygen had reached the level needed to sustain aerobic or oxygen-based metabolism. Aerobic metabolism increased the cell's ability to downgrade energy stored in the glucose molecule, and metabolism became more efficient. With the advent of aerobic metabolism, the simple prokaryotic cell gave way to the complex eukaryotic cell, and evolution progressed at an accelerated rate. About 1.2 billion years ago, sex and genetically programmed lifespan emerged. Ancestry began, and successive generations formed a lineage. By about 800 million years ago, heterotrophy, or the feeding by one species on another, had become widespread, and the biosphere reflected the complexity of this interaction. Then, by about 750 million years ago, the creative process had exhausted its potential to advance through the evolution of unicellular life. The universe crossed the threshold to the multicellular organism. By way of the creative process, new, more complex and conscious species emerged, and old species declined and fell into extinction. With regard to the Earth as a whole, events of mass extinction denoted periods of significant biosphere realignment. Paramount is the mass extinction that took place at the end of the Paleozoic era, the period from 540 million years ago to 250 million years ago. Also paramount is the mass extinction that took place at the end of the Mesozoic era, the period from 250 million years ago to 65 million years ago. Marked by this extinction event, the universe's ascent locked in the evolution of the mammal and of the primate line, the branch that would lead to ourselves. About 100,000 years ago, the universe crossed the threshold to reflection, and life itself fell into evolution's trailing arrow. The evolution of the biosphere no longer took place in support of more advanced organic forms. The evolution of the biosphere took place in support of what had become the leading edge of the universe's advance, the human drive to understand itself and its world. Marked by the threshold to reflection, the biosphere entered a period of decomplexification, a trend towards simplification defined by a reduction in the number of species and ecosystems. Did the universe's threshold to reflection unfold in modern humankind or in archaic humankind? What in the fossil record denotes this transcendence? With our look at the early Earth, we complete Session 1 in our course on humankind's reconstruction of our planet's urban and ecological infrastructure. We have the background to examine the building site, that is our planet, in human terms. Our course titled Blueprint for Reconstruction continues in Session 2, Reflective Earth.